welcome to the show. It's me, John Park, and this is John Park's Workshop. It's the first one of the new year, so welcome everyone to 2021. And I want to say hi to everyone over in the Discord chat. Thank you for stopping by over there. If you want to join in the chat and you're over on YouTube wondering where is everybody, or maybe on Facebook or Periscope or one of the other many places that we broadcast the show, the answer is usually Discord. You can go to adafru.it/discord and you'll get an instant invite, and then you can go and join in on the fun. The people over there right now that I want to say hi to, well, everyone, of course, C. Grover, Andy Calloway, Todd Bott, Mr. Certainly, Trekker Geek, Whoa 007, Adam Katalak. Hello, 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 everyone. Thanks for joining us. Hello, Ken Santema. Is that everyone? I think that is. Jim Hendrickson, hello. I hope I got you all. And so let's, without any further ado, get into the show. First thing, you might not be able to tell very well, but I cleaned up and organized the workshop over the break, over the last few days of the break. Actually, my daughter and I got a bunch of stuff put into these metal bins that I've got, these shelves. I got a whole bunch of these kind of guys. I'll do a shop tour. This is actually the impetus behind this. My daughter said, you should probably do a shop tour of some kind where you can move a camera around. I said, oh, my piles of junk are so shameful. I don't want to do it. She said, all right, let's get organized. So things are actually in better shape than they were, which is great. What else? Let's see. Hey, hello, Charles Burniford. Hello, Gary Z. Thanks for stopping by the Discord chat. So here we are, 2021. We've got some projects. I'm going to be working on a MIDI controller using the Guitar Hero controller today. Show you that project that I've been working on. I'll show you a little recap of my product pick of the week. We'll talk about our, oh, that's a popular, Whoa 007 says shop tour. Yes, all right. I actually did one a few months back for the virtual Miami Maker Faire. Got a few cameras set up, cleaned things up a little bit. And unfortunately, my interface caused it to broadcast through Zoom at like 300 pixels wide. It's tiny, so you can check it out if you want, but I'd like to do a better pre-edited, glorious-looking one at some point. Maybe get a good fisheye lens to do that. The Ken Santema says, is it possible to have a proper shop without piles of junk? I've seen it done, but it's not my style. I admire it, especially in very clean wood shops and machine shops. What else? I've got a Make Code Minute to show you. Cool little project using a tiny robot. I've got a Make Code arcade game pick of the week. Probably a couple other things in there. I don't think I have a shop tip this week, but I'll work on preloading a list of those too, so I can show you those. All right, yeah, let's get into it. Why not? Okay, so first of all, I've got to mention that we've got a jobs board. There it is. Help wanted. Go to jobs.adafruit.com, and that's our free job board. You can post a position that you're looking to fill. You can post your resume if you're looking to get hired. Up here, we've got a few from none new to 2021 yet. Who's going to be the first? Who's going to be the first person to post a position for 2021? This is from December. There were a couple of posts in here that looked interesting. Community game designer for Hack Club, as well as director of resource development for the Python Software Foundation. So if those look up your alley, go check it out. Let's see. Oh, one thing I wanted to mention, there was a lot of cleanup going on over the week, and cleaning out some toys from my son's closet. He didn't want that Woody doll that you see back there anymore, so I nabbed a Woody, and we'll see how Woody and Lars get along. They're trying to figure out where they are in the hierarchy, I think, right now. Could be interesting. What else? So that's the jobs board. Also, if you didn't know, when you go to adafruit.com and place an order, I believe we still got a bunch of free stuff available. So I'm going to do, let me go to adafruit.com/free, and you can learn all about it. Let me pull up that page for you. deals and more at Adafruit. So you can get a free Perma Proto half-size breadboard if you spend $99 or more. You can get Adafruit Stemma QT quick board, breakout board. I think there are 15 different ones you can get, and you'll never get the same one twice until you go beyond that. That's for orders over $149 or $149 or more. At $200, we have UPS free ground shipping in the continental US, and for orders over $299 or more, you got your Adafruit Circuit Playground Express you get for free. So go check that out if you need a reason to put your eggs in one basket and hold off on some small orders and get a bigger order together. That might be worth considering. But I don't want to stop you from ordering, because that's what keeps the lights on here at Adafruit. So we're very happy that you're getting good stuff. We've been really happy that people are still ordering cool, fun parts from Adafruit to build their projects. Let's see, what else we got? Free stuff. You know, every week I do a show on Tuesdays that's called the JP's Product Pick of the Week. And this is this week's episode. That was on Tuesday at this same time, so 1 o'clock Pacific, 4 o'clock Eastern time. And the product pick of the week this week was this Wii Nunchuck Adapter, which I'm going to talk about in some more detail, actually. But let me show you a recap of that show. So this is our product pick of the week. This is the Wii Nunchuck Adapter. This one is the first one that I know of that has the little Stemma QT/quick connectors on it. And this is using a Wii Chuck plugged into our little Stemma QT Wii Nunchuck breakout adapter. If I go up on Y, it increases the number of neopixels. Down on Y, it decreases them. If I tap the Z button here, I can cycle between some different colors. I also am using the accelerometer for brightness. With that C button held down, I can now adjust my brightness, and of course it'll read all of these at the same time. That is the product pick of the week. It is the Wii Nunchuck breakout adapter using Stemma QT. I almost fooled myself. Got that audio back on. Yeah, so that was product pick of the week, and here it is right here. As I mentioned during the show yesterday, these have existed for a long time. I'm gonna say a decade or so, maybe more. Toddbot is in the chat. He was one of the first people to build a little shim type of breakout for the Wii Chuck. Here's what the port on the back of these looks like, and it's the same for everything that plugged into the Wii Mote. So this, in this case, is the classic controller, which is very cool. But that is I2C, and this is the first version that I've run across that has the little quick connectors that we can use to plug into Stemma QT boards, which makes it really easy to work with. And it also has the little pins that you can, or pads you can solder some pins into if you want to put it on a breadboard or a Perma Proto board, that sort of thing. And the thing that surprised me after, it's been, like I said, probably a decade since I used these, is the wide variety of peripherals have been put into the library on Arduino. So we have a Circuit Python library, and we might be updating that for some more of these peripherals. But I checked the Arduino library, and now it works with a whole bunch different peripherals. In fact, someone just mentioned, Mr. Certainly mentioned the SNES Mini and the NES Mini. I just coincidentally had moved this, this is my SNES Mini, and yeah, sure enough, if you look at the controllers that come on that little sort of reboot console, classic reboot console, same thing. So I haven't seen, I haven't plugged that in and tried it yet, but I'm guessing there's some chance it'll have the same messages as that Wii Classic controller, and if not, maybe someone can analyze the data coming off of that and make it work. So we have a lot of options there for those devices, and we'll be looking at one today in the project. Yeah, in the chat, actually, Whoa007 says, I wish I'd held on to the Guitar Hero. Green Eggs and Ham says, you can find them sometimes at Goodwill, for sure. There are so many, excuse me, of these add-ons, particularly Guitar Hero controllers. and they're very cheap, a few dollars at Goodwill. You can get them, probably go on eBay as well. All right, so before we go any further, I think it's time for a Make Code Minute. Aha! Just got my audio turned back on. Let's try that again. I bet the audio alert sound is going to buzz here in a second. We'll see. Yeah, my stream is catching up, and now people are saying, muted. Sound, please. All right. How embarrassing. Nothing changes. Yeah, okay, it's 2021, but I'm still making that mistake. One of these days, I'll get it right. Can you hear me? Can you hear me now? Oh, yeah, if you were hearing me, it was over that other mic back there. That's right. Funny. Okay, now we're at 100%. Okay, let's do this again. For the Make Code Minute today, I wanted to show you the Qt-Bot. This is a little robot platform that you can use with the microbit, and you can code it inside of Make Code. So if you look inside of my Make Code session here, I have added the Qt-Bot extension through advanced extensions. And in this extension, we have a whole bunch of very specific blocks for driving the motors and lights and sensors that are built onto the little Qt-Bot. You'll notice the Qt-Bot has a little ultrasonic sensor there, so I'm going to use that in this script. If you look at my code, you'll see that I have set the sonar, turned on the sonar unit. I've got a variable called sonar, and I'm measuring it in inches. And then I've got a little loop that says if the sonar is less than 3, so if it detects something less than 3 inches away, we're going to let the left wheel spin at 20%, the right wheel spin at 20%, actually both negative in that, so it'll go backwards. And we're also setting a little headlight neopixel color. When that is no longer true, we'll stop the car immediately, and the headlights will turn red for stop. You'll also see my little, in case the wheels are running when you start it. I show a little icon here, and there goes the alert button. I think you can still hear me. On start, I stop the car immediately. I show this little icon on the LEDs, and then I set this neopixel strip so that it's ready to go, which are these little lights on the front. So I'll turn it on here, and you'll see it is in its stop mode. When I put my hand a little too close, it scoots away. So this is this cautious little friend, little car buddy, who does not want me getting too close. We can encroach on him, and he'll keep backing up. Get out of there. So that is the Qt-Bot, and that is how you can code it right inside of Make Code using the microbit Make Code. And that is your Make Code Minute. All right. Let me pop back in full screen. By the way, inside behind the scenes stuff here. The reason I so frequently come back from something like that with my mic off is that I turn down that channel when I play audio that I'm going to hear myself through my speakers so that it doesn't echo. And I'm sure there's a better way to do that, like a small monitor in my ear or something, but I'm not currently doing it that way. So if you wonder, why does my audio go out? It's me. I turn down the knob on that channel of my mixer, and then I return and happily start moving forward with the show with no audio. Yes, Toddbot says that is a social distance bot. Aren't we all now? I believe we're all now social distance bots. Pretty sure. All right. And thank you, C. Grover, who said the audio alert had a 2-minute latency. That's no good. It's time to maybe come up with a new way of running the audio alert system. All right, lots of systems and things here. But I'll probably doom this, but it sounds like my lag has not happened. My audio is in sync, which if you watch my Tuesday show, you'll know that show for some reason has audio desync. This one doesn't, and I am still trying to analyze my 2 different templates to figure out why. All right, well, next up, how about we take a look at the Make Code Arcade game pick of the week. So let me swap over here to different view. That'll work. So my Make Code Arcade game pick of the week is Naruto Fight by Dabix LP. If you take a look, this is on the forum.makecode.com arcade forum. You'll see, you can click on this link to check it out. Also look at the little discussion here, including instructions. So this is a fighting game. You use B for blocking, you use A for punch, and then there's some combos. Down A for kunai throw, down A and B to clone jutsu, but you need to gain 60 chakra first. A and B for kicking, and so on. I'm just going to mash buttons, but let's take a look at it. So here I'll start it up, and let me jump out of the way. Okay, yeah, B for blocking, and then I did a combo there. I can jump over, hiya, and you can see your little enemy. I don't know Naruto, so I'm not going to get anyone's names right, but down an A. Oh, throwing stuff there. Ha, hu, ha. All right. So I'll stop it there because I obviously haven't played it much. But I thought that was really impressively executed. And if you want, you can head into the code to take a look at how it's all set up, as well as to give yourself some power-ups and other sort of edit the code if you'd like to give yourself your own combos and things. But a very cool game, nicely animated. If you take a look at inside the code, even in the JavaScript mode, you can open up the little sprite editor and take a look at these beautifully drawn sprites. So fantastic job done by Dabix LP over in the arcade channel on the forum.makecode.com. And that is my arcade game pick of the week. It is Naruto the Fight. Music. All right. Let's jump into the project of the week. So, as I mentioned, in Arduino, the library called Nunchuck has now got support for a whole bunch of different controllers. And what I'm going to do is I'm going to take you through a little bit of the code that I've written for my guitar over there, and then I'll show you how I've set it up and do a little bit of a demo. Show you some of the things that you can control with it. So let's jump over to the code here. That'll work. And let's see if I can just move this over. And in fact, I'm going to jump into this view so that I can make that window a little wider. So you'll see my code is not optimized. So I wrote this very it's not optimized. What's the word I'm looking for? It's fat code. So I could optimize this, and maybe I will before I put this out in a guide, but right now you're going to see a lot of repetitions of things like if statements. Sometimes that helps with clarity. It certainly helps me think about how I'm doing it, but there are 10 buttons, so it's right on that verge of where you might want to optimize things a little better with switches or with arrays, but right now I've got a bunch of if statements, so that's your warning. You'll see here we're including the Nunchuck library as well as Adafruit Tiny USB and the MIDI library. So with that combo, we're going to be able to use this as a USB MIDI controller. If you wanted to, you could also use it as a sort of classic serial MIDI controller. I don't have it set up that way. I'm actually using a Cutie Pie. So you know, here's one that's I've got sitting over here that's got things sprouting out of it. But there's your Cutie Pie, right? So it does have pads that we could connect some wires to and use a sort of classic 5-pin DIN MIDI or a 3-pin TRS MIDI. But right now I'm only using it for USB MIDI. And what this means is that it acts like any sort of MIDI input device that you'd plug into a computer or something else that can host a class-compliant controller. So things like iOS devices you can use with an adapter, any computer you can use MIDI on, and then some hardware synths you can use, or you can use a Raspberry Pi to host the device and then send out USB MIDI itself. So you'll see what I'm doing here. I'm creating the Nunchuck accessory with this command accessory guitar1. If you look at the code for the default, it's going to say Nunchuck 1. You can change that to any name you want. I've decided to personalize this one as guitar. Then I'm creating the USB MIDI, and this instance is using the MIDI library over the USB MIDI transport. And this USB-D, I found out last night, stands for device. There's also some provision in TinyUSB for using a host instead of a device. So now I've got a few variables that I set up for, in this case, just a user mode. So there's a Strum Bar. If we look, let me pop to the overhead for a second. In fact, I can just set that as our background here and move this. So if you look at the controller, there's a Strum Bar. In fact, let me give you a good tour of the device before we talk about the code. So the guitar controller has two buttons here that sort of act like one button. I'll show you why in a second, but this is the Strum Bar that moves up and down. There's a plus and a minus button. Those are often used for things like menu items. I can't remember if you can use them in the game. This Whammy Bar is essentially a potentiometer. Allows you to get variable analog readings. There's a joystick here, so you get X and Y. And then there are these 5 buttons on the neck called the fret buttons. So the Strum Bar I'm using as a, in this mode, I'm using it to send MIDI chords. So any of these buttons could be configured to send MIDI note messages on and off. Could also be used to send MIDI program change messages, which is something like switching which patch or synth sound you're using. Can be used to send MIDI CC, which is typically a variable thing like a knob or a slider. But I'm going to use, in this case, the strum either as single notes, 2 different notes, or 2 different chords. So that's how I have it set up when I say it's in chord mode by saying int strum equals 1. And we'll look at in a second how that works. And then I'm creating these variables for Whammy Bar, joystick, X, Y, the minus and plus buttons. There's the strum up and down, green, red, yellow, blue, and orange buttons. So those are all going to have values that we read using the Nunchuck accessory library. And then I'm also setting the state of when a button is pressed or when it's released, because the way this works in MIDI, we will send one MIDI note message when we press the button, and then when it's released, we'll send the MIDI note off message. And then we will also use a little variable I created called Octave. It's a little confusing how I've written it, but essentially I'm saying the starting point is whatever my note values are, they're going to increase or decrease by 12, which is how many notes in an octave in the chromatic scale, when I press those minus and plus buttons. So initially, my offset is 36. So I think if I might have changed that. I thought I had that at 0. Let me see. Does this need to be refreshed? Yeah, I won't refresh that. I might break it. But I think I have that set to 0 at first. Then what I've got here are some variables for the strum note when I press it down and up, or the strum chord when I press it down and up. So I'm going to be using this chord mode, so that means I'm sending these notes, which is like a C major scale or a C minor scale when I strum up, so I've got 2 different chords. And then I have assigned a note to each of the green, red, yellow, blue, and orange notes, and those are actually 1 octave lower than where that Strum Bar stuff sits. The Whammy Bar, I looked in my serial port like I did on my show on Tuesday and just moved things and saw what values I got. It goes about from 16 to 26. If you lift it up a little, it goes to 15, but that's not where it sits. When it's just not being touched, it sits at 16. So that's kind of my starting point for the low end of the range of what I do with the Whammy Bar. And then the Whammy CC number is which control change on your synthesizer is this being used for? I'm using it for a thing on MIDI CC number 1, which is usually the mod wheel. So if you've ever seen a synthesizer that has a little wheel on the left side that you wiggle, it's usually next to a pitch bend wheel. It often controls things like a filter frequency for a filter sweep. So that's what I'm using this Whammy Bar is to send out on MIDI 1. In your software, you can reassign that. So by default, it'll try to be a mod wheel. I actually have it set up for pitch bend on my software, just because this was easier to do it this way versus the separate MIDI pitch bend message. And literally it's because I was too lazy to open up, hey, what does that exact message look like? In fact, you can see I was about to go down that road. I don't end up using this in my code. This was going to be, that's the center point. Most MIDI CCs are 7-bit values. I think that's right. Yeah, 0 to 127. The pitch wheel is a, what is it, 12-bit? Someone tell me in the chat. It's either 12-bit or 16-bit, and it does 0 to 16,000 something. So the middle point is 8192. Whammy Bar is CC message 2. Oh, is there a Whammy Bar message? I didn't know that. That's cool. So then in setting up the joystick, again, these I'm using numbers that I found just through trial and error, and it probably varies by guitar, especially an older one. This one's been used a lot, so the potentiometer is probably a little gnarly. Oh, 12-bit, Charles Bernard says. Thank you. So pitch bend is 12-bit. So my last joystick value and my current joystick value, I'm using that to notice the state change as I move it, so it's not constantly sending stuff when it's not moving. So I set it to 23 on the joystick. I'm sending out over CC number 71, which is also typically a voltage control filter value, either the Q or resonance or the frequency, I forget which one. And the value initially is at 0, again, so I can compare the value and the last value. Same with the Y axis on the joystick, that one happened to sit at 224. Then we set things up. So in this setup loop here, we set serial this is just for printing out messages. I actually don't need this now, I think. Then we begin the MIDI on MIDI channel Omni, and that you could set this to a specific channel, and I'm not reading any MIDI in, so there's no real reason to be on Omni, but I happen to be. And then I start that accessory. So remember, this is using that Nunchuck library, is the whatever you name it .begin. And then I'm explicitly setting the type of accessory for that library as Guitar Hero controller. That's in the library. You can have it figure it out by reading some sort of initialization string when it starts. But if you're not planning on plugging different devices into something, you can just say explicitly what device it is. That may be particularly helpful if you use third-party controllers, because they may not have the same message that the branded Guitar Hero controller is going to send. And then here's my main loop. So this does all the magic. This is the Nunchuck library's read data. It reads the full set of messages coming from the device. And then in the example I showed on Tuesday, I was just printing those out, and we could see them all show up. What I did was look at those and see which ones do I care about. So you can see it's this big array of values, and value 0 is whatever the Whammy Bar is doing. Value 20 and 21 are the joystick on X and Y. And then you can see here the minus and plus button happen to be values 6 and 16. Strum down and strum up. Remember earlier I said that one's kind of weird. The strum down and strum up show up on the same essentially channel, this values index number 7, but their values are discrete. So it actually sends a 128 when it's in its sort of off position, and it sends a 0 when you, I think, is 0 when you strum up, and a 255 when you strum down. So we can read those and know what to do with them. But it makes that one a little funkier. It's funny that it's not coming across as two different values, especially because if I recall the last time I opened one of these up, there are two separate mechanical keyboard switches sitting under there. There was like two Alps switches. Then these ones are the most straightforward. These are sitting on 10, 11, 12, 13, and 14, and those are the neck buttons. And then we get into what I'm doing with these. So for Whammy Bar, you can see, yeah, I wonder, I think I'm not doing this way. I don't think I'm sending those values. Maybe I am. Sorry about the confusion. I think this is an unsaved file, and I edited this. Oh, what the heck? Let's be dangerous and try to reopen it and see. Let's go to Arduino. Let's see. Is that really what I'm working with? Where? It seems like I am. Am I really sending pitch? Maybe pitch bend is 1. No, that's not right. Something's goofy there. Oh no, I am sending pitch bend. Okay, sorry about all that before. I guess I did this late last night. Yeah, I am sending pitch bend with this. I'm not sending over that. This is a red herring. This Whammy CC number, I'm not using that anymore. So I am sending pitch bend. I am just sending the pitch going up, and it can go up 2 octaves, which is sort of the default for this 8192 to 1638. And I'll demo that. I promise I'll demo all this in a moment, but that's going to take whatever note we're on, and varying as we press that Whammy bar, it's going to go up through not 2 octaves, 2 semitones, or 2 semitones. Octaves would be terrible. And then after it, so the way this one's working is it's checking the Whammy bar value and making sure that it is different from the last Whammy bar value. So that's detecting a change, and then at the end of that we set the last Whammy variable to be equal to whatever it currently is. Then with the joysticks I do it a little differently. You can see here these are mapping, sort of remapping the range of, again, customize. The joystick on X only outputs the numbers 190 through 255. Same with Y. Don't know why. It varies. The Nunchuck does one thing, the DJ turntable does another, so there's this kind of really short range of values that are coming through there. And I'm remapping them to be the full 0 to 127 range of a control change. And then when those are when those are changed from the last joystick value to the current one, I'm sending MIDI control change message. So pitch bend for Whammy bar, control change message for the joystick, both X and Y axes. And it sends over the kind of channel that we're using, whatever that current value is that we remapped. Then here's how I'm using these octave buttons. Let's see, I'm going to clear that out just for clarity right now. So this is the plus and minus buttons down at the bottom of the guitar, which oddly are, the minus one is closer to you and the plus is further, so it feels kind of backwards because you push the lower one to go up. But here's how these work. So if the minus button is at 0, which is its pressed state, and the minus button on state switch that I've made is also at 0, then I'm changing this octave. I'm dropping this octave value by 12, which is 12 notes in the octave. And I'm putting that into this range. I'm constraining it so it doesn't like just keep going lower and lower and lower. I'm constraining it between 0 and 108. And that's just because it loops around. There's probably a better way to do this, but I'm using essentially that same logic for the plus and the minus. Here's the plus. And again, when it gets actually up to 108, if you hit it again, it's going to loop over. But you've now traversed like 8 octaves, so probably you shouldn't be up there. Let's see. And then here's my Strum Mode stuff. So let me make a little space here. So if I'm not in Strum Mode, if I'm in not in Strum chord mode, if I'm in note mode, which is what this is checking, then these just send some notes. And the way note sending works is it's whatever note we defined up at the top, plus whatever that octave sort of offset is that I've made. Maybe I should just call that offset. Octave is a little confusing. And that sends this send note on message, which plays the note. And then when I release that, we send the send note off message. The way this is constructed is it's the whatever the note number is. So let's say 60, which is a C. This is the velocity. So you have this 7-bit range of velocity values. So on touch-sensitive keyboards, you can press lightly or hard. I just have it always sending at full velocity because these are not touch-sensitive buttons. And then this is sending over MIDI channel 1. You could probably change this. I mean, you could definitely change this. You might add a little variable for yourself at the top. You could also change it on the guitar. You may even come up with like a key combo on the guitar, which allows you to change MIDI channels on the fly if you want to. The cooler thing, I think, is this: if we are in strum mode, which is the chord mode. So if strum mode is true, which is chord mode, here's what we do instead. We still are doing the same detection on a press, but then we loop through the little array that I made. So for C, which is the variable I chose for chord, C is equal to 0, C is less than 4, and then C++, that adds, oh, that's kind of confusing. It adds 1 to it each time. We just run through the array that I have of those 4 notes in the chord. You could have that be as big as you want. So send them all. I think some versions of the MIDI libraries I've used in Arduino allow you to kind of gang up a bunch of messages and then send them at once, which you might want to do if that chord gets any bigger. I'm mostly using it with an arpeggiator, so it doesn't matter, but you could start to detect that they're not all being hit at the same time if you do it this way, but for me, in this case, it worked pretty well. Same logic happens on note off, and same logic happens on strum up. And then finally, these are the simple ones. I should have probably started with these. So if green button equals 255, which is its pressed state, and its state is saying I wasn't currently pressed, so we detect the change. We send a MIDI note on of whatever that green note is, plus that octave offset, 127 velocity on channel 1. Repeat, and that is it. Oh, I have a delay in here I was using for, that doesn't really need to be there probably at all. I was using that for looking at print statements, so that might be on the guitar over there. But enough talk, let's do a demo. So I'm gonna hop over here now, and there we go. So, oh, I just noticed Charles Burnford said the pitch bend is on CC12 and it's 14-bit. Okay, I'm getting that all wrong. So what I have, let me log back into this machine and then do a proper demo. So, okay, so what I have here, I'm using, if I can pull this under the camera or not. I'll point it at that camera. Let me make that camera the big one. Okay, so you probably can't see much there, but it's a laptop with a bunch of interface on there. This is a free synthesizer app called Helm. I really like it. It's very straightforward, and it kind of shows you everything that's happening with the way your synth is patched, and it has a lot of great presets. And it has MIDI input. So right now, I've got that code that we were just looking at. I'll go back to full screen here. I've got that running on the Cutie Pie. A little cricket has decided to join us. So there's the Cutie Pie plugged into USB, and then I'm using the Stemma QT connector to plug into my adapter for the Nunchuck Adapter, and then that plugs just into the guitar accessory. I haven't really made any modifications to this guitar yet, so I'm just kind of bending the plastic Wiimote door a little bit to fit that cable in there, and I may put a hole in it and do it a little more elegantly later. But so there you can see, there's the connection being made. But essentially everything is being done over USB. So right now if I press a note, So those are the notes that I mapped on here. And so this is just sending those MIDI note on. This one happens to have kind of a slow attack because it's this pad sound. But you can hear if I hold a note and then use pitch bend on it. And we can also play chords. Now on the strum bar, I said I've got chords also, so check these out. I'm just going to push the strum bar down. And I'm trying to look at the chat. It's kind of far away, but let me know if you can or can't hear either the synth sounds or me talking on top of that. I'm going to double check real quick to see. Let me know. Matambale asks if I'm taking requests. There's not I don't think I can play Freebird on this thing. I don't have enough notes. Do I? Probably not. I like making instruments and goofing around with them more than trying to learn how to play actual songs. Truth be told. Okay, so those are pretty cool, but what I'm going to do now is change which octave I'm in. So if I play, let's say, one of these chords, and then hit my plus key, my plus button down here, you can see it's pretty wild up there at that upper register. I'm going to drop down one. One reason I'm doing that is in that range we hear these filter frequency adjustments a little better, which is what this joystick is going to do. So check this out. Let me drop it down. And I actually didn't map anything to the Y yet, and partly it's because it can be difficult to use this precisely on one axis at a time, which is what I wanted to do. But what I want to do now is show you one other synth patch that I had picked. And again, like I said, you could set this up so that there's some key combo on the guitar maybe that sends out a program change. Maybe make the minus key do flip between different program changes, and the plus does the different octaves, and they're sort of separate from each other. This one's an arpeggiator, so there I'm just holding one key, and it's doing this arpeggiation at a certain tempo based on what the synth wants. Now, as you press different notes, instead of playing kind of a chord at once, it's jumping between different notes in this arpeggiation. And we can change octaves again. I'm going to drop this down a little. Also, one interesting thing I've noticed is that, oh, did I not? Sorry, I realize I'm not actually showing that workshop cam properly. Let me swap. Yeah, my little key button didn't switch to that. All right, so you can see me. One thing that's interesting is that if I, this is kind of a common problem in MIDI controllers, is that if you never send the note off message, it will just keep playing a note kind of forever. So usually there's a button or some provision for sending what's called a MIDI kill, MIDI panic it's called, and that just sends the off message for every note. It just kind of whips through 0 to 120 or whatever it is, 128, 127 of the MIDI notes and turns them off. I probably should set that so that's what happens when we change octaves, because what's happening right now is kind of cool actually. I can hold a note down, and then when I switch octaves, it'll just keep playing that because I've never sent the note off message. So check it out. So now it's just going to play that. And now when I press that same note, it's in the other octave. And we can do that again. So now I'll have to turn them off by going to that octave and pressing and releasing it, which finally sends the note off. I thought that was kind of cool. So let's see. Yeah, I think that's it. That kind of covers what's going on with this. I think it's a really fun way to kind of reuse a thing you may already have and turn it into a very cool MIDI device. And even if you have no other kind of music instruments in your life, if you've got a computer, which I think many of you do, not everyone, some people use a phone to watch this, but if you have an iOS device, you can do this too. You just need like the little camera kit adapter, they call it, that allows USB to plug into the iOS device. But a computer or an iOS device allow you to use a Guitar Hero controller plus a Qt Py, which is a $6 microcontroller, and this little adapter here, which is about $3 or less. And find yourself you might have one in your attic or basement, or go to a thrift store, or don't go to one but get one online from a thrift store. You now have a very capable MIDI controller that can be used for some very interesting things. One thing I like about this is it doesn't force you into the constraints of a piano keyboard style MIDI input device, which is the most common by far. If you just look for a cheap, you might get one for like $65 to $100 for a cheap USB MIDI controller online. It's going to be a keyboard with some knobs and things. I probably have one around here, but this is, very cheap and very different. It's going to encourage you to do things differently than just a simple piano keyboard style keyboard. Ken Santima says that looks more fun to play with now than playing Guitar Hero. Yeah, it's kind of more fun because you have agency. You're deciding what notes to play, not deciding when to hit a button because of another note that's coming at you. Those are fun too. Those make you feel like a rock star. But this is pretty neat. I think I have a few of these controllers. One of them is I think it might have been Guitar Hero World Tour or something like that. It has a touch strip in the neck as well, and I think you can use those as separate things from the buttons, so you could get 10 different notes out of it. I think some of them may have accelerometers in the neck, but that may only be on ones that are USB. I think the ones that had a Wii mote in them just relied on the accelerometer that was built in the Wii mote. So you probably won't get accelerometer there. But guess what? This is Stemma QT, which means we're all about linking things together. So if you want to add a light sensor and a accelerometer and a magnetometer to a gizmo like this, it's as easy as plugging in one more Stemma QT device into the Qt Py and writing up the code. So yeah, Green Eggs Ham says it would be great if the keys could get velocity too. That would be very cool. I'd say that would be a taller order. I know some velocity-based things use sort of two switches and the differential and timing between them, but you'd be doing a pretty advanced hack on this at that point. All right, let's see. I think we're just about out of time. I think I've covered it all. Let me know if you have any thoughts or questions over in the chat about this controller or anything else we were up to today. Oh, I'm going to have a look over real quick in the YouTube chat. Let's see. Yender MC says, this is awesome. Don't have to butcher the guitar. It's true. Yeah, the last time I did a Guitar Hero guitar hack, I was using it with a Circuit Playground Express inside of MakeCode, and I just soldered some extensions and alligator clips directly to a bunch of the switches. So that was a much more invasive, time-consuming. I'm really excited that now you can just plug right into the output of that the way it was meant to be. Let's see, what else? Is this only for the Wii-based guitars? The Xbox ones won't work. Yeah, so the Xbox and PlayStation guitars are USB devices already. So you won't get USB MIDI out of them, but I believe you get USB HID, and there may be, so it'll send key presses basically. I'm not sure if any of the analog stuff works in that case, but look into Clone Hero. Clone Hero is what people play on the Mac and the PC. It's what all the streaming guitar people use on Twitch. And there's a lot of people in that community talking about things to adapt their USB-based guitar controllers to their computers, or just go directly in and use the use software and drivers to deal with it. So yeah, I think a lot of those will just show up as a game device using USB HID. So, but I don't have any of those. In fact, I only have these Wii ones, so now I get to use them. Let's see, anything else? The Discord chat is just full of puns, so if you like puns, head on over there. I won't repeat them now. You can just go in and read them. Yes, Steve, okay, you're on, says that the velocity is not really doable with the basic switches that are in that guitar. Yeah, so I think it could be a fun project to try to figure out a way to do it using a second switch and time of flight or whatever, but it's not a basic hack. Anything else? I think that's it. Crisley Cruz says, could this Wii adapter be used to use game controllers in emulators over USB? Yeah, sure. So if the game controller you're talking about is like this Wii Classic controller, and it has that little accessory port plug on it, or like I was talking about earlier, the SNES Classic and the NES Classic controllers also use that, then that means they're sending over I2C. They can get plugged into your QT Py or anything else using our little Wii Nunchuck adapter. And then at that point, something like the QT Py can act as a USB device. So it can show up as a joystick, or it can show up as a keyboard, or it can show up as a USB MIDI. There might even be other things, but those are the three big ones that I know. All notes off, Steve said earlier. Yeah, that note panic. I need to look into adding that probably. Otherwise you get stuck. All right. Sounds good. Okay, thank you everyone for stopping by. It was really nice to hang out with you on this first John Parks Workshop of the new year. And I look forward to seeing you all again real soon. And I will hang out in the chat over on Discord a little longer. So I will see you. Thanks everyone, and bye-bye.